Okay, class, now let's go to chapter 2, which is about the geology of Ethiopia and the whole. So it begins from the definition. So what is geology? Geology is an earth science that studies the evolution of the earth, the materials which it is made of, and the processes acting upon them. So it's a broad concept. Okay, it's a broad concept. So there are many such clues, not only the rocks and landforms, which can be observed and studied at their surface, but also those provided by indirect methods such as geophysics. Okay, it studies about geology. In here, what's most important is that we need to study about the different continents. So there's continents where once bunched up together into a single huge continent called Pangaea. Millions of years ago there was a Pangaea. So the large supercontinent would then it started to split into what we call it Gondwana land, where Africa is part and Laurasia, and later into smaller fragments over the last million years. This then drifted apart to form the present arrangement of continents, meaning that finally it gave us the current shape of continents. Continents were once assembled together as a supercontinent called, the study shows that many million years ago there was one huge continent assembled together, and this is called the continental drift theory. The continental drift theory teaches about how continents were once assembled together million years ago. Wagner, a social scientist, a principal observation, this person, Wagner, his principal observation to show that continents were once assembled together are 1 feet of the continents. Meaning, if we take the present day continents and you bring them together, the opposing coastlines of continents often fit together. 1, 2. Much of mountain belts, rock types. If the continents are reassembled, if we are to reassemble it as Pangaea, mountains in West Africa, North America, Greenland, and Western Europe match up. They match. If we are to bring them together, they do have a similar rock types in these different continents. The third evidence of Wagner is that the distribution of fossils. The distribution of plants and animal fossils on separate continents forms definite linked patterns if the continents are reassembled. Meaning that if we are to go to these different continents and see, the fossils, they do have similarities of the plants that were grown in these different continents. The first one is the paleoclimatic climates. That is to say that rocks formed 2 million years ago in India, Australia, South America, and Southern Africa are exhibited evidence of continental glaciations, meaning there was glaciation, a huge cover of glaciation was seen. So when we see the geological process, we need to see 2 things. These are the endogenic and exogenic forces. These are the forces, that we have to observe on Earth. We say geology studies how Earth's materials, structures, process, or organisms have changed over time. So these processes are divided into two major groups, internal and that of external. The internal process is called endogenic, which includes volcanic eruption or activity and all the tectonic processes. By tectonic meaning that folding, faulting, orogenesis. Orogenesis refers to mountain formation or building, and epirogenesis meaning slow rising and sinking of the land masses. All these are seen, okay, within or to be studied within the endogenic process. These processes result in building of structural and volcanic features, meaning the endogenic processes have formed what we call it features like plateau. Plateau means a flat area on the top of a mountain. Rift valley, a valley that is to be formed by that of faulting. Block mountain and volcanic mountain. All these are to be seen because of endogenic processes or internal processes. The second one is external or exogenic process, which includes weathering, meaning that weathering is meant by the wearing away of the land surface. 2. The mass transfer, okay? Soil and other materials could be transferred from one area to another area. Erosion, and when a huge amount of sediments are to be transported from one area to another, we call it erosion. And what has been eroded will be deposited, what we call it deposition. All these are external processes. All these forms act upon the volcanic and structural landforms by modifying. They modify it, they roughen it, they lower it. So we will see different landforms in different periods of the earth. Now in geology, what is most important is that we need to see the geological time scale and age dating techniques. We need to know it. In which era, which kind of landforms were observed has to be studied in geography. Then we will see how the different eras differ in terms of the different landforms. So the geological history of the earth is divided into eras, and each era is divided into periods. The eras are given names that indicate the kind of life that existed in them. By identifying the different life which existed at different times, eras do have different namings. For example, the Paleozoic era is the ancient life, is the age of invertebrates, meaning that invertebrates are animals without backbone. So the era where invertebrates were seen was termed as the Paleozoic era. The Mesozoic era, the middle life, is the age of reptiles. Reptiles are different animals which will go from one area to the other, okay, by contracting and relaxing. Reptiles, for example, like that of lizards and so on and so forth, could be seen as reptiles. The third one, now before we go to the Cenozoic era, what we call it, the recent life. The third type is called, or time scale is called, the Cenozoic era, is the recent, meaning that the current age. This is the age of mammals. Mammals that will feed their, infants. We call them mammals, including humans are mammals. So the earth, according to geological study, is believed to have been formed approximately 4.5 billion years ago. Look how it is an old planet. The earliest forms of life were thought to have been originated approximately 3.5 billion years ago. So the span of time before life appeared, okay, before the appearance of life on Earth, where life was not existent, is termed the Precambrian era. Meaning the Precambrian is the oldest era where life didn't exist there. So to describe the geology and history of life on Earth, scientists have developed the geological time scale. The geological time scale measures time on a scale involving four main units. These are, first, an epoch. An epoch is the smallest unit of time on the scale and encompasses a period of millions of years. A period of millions of years is termed as epoch. Chronologically, epochs are clumped together into large units called periods. So, different epochs will form one period, like the Precambrian period, and so on and so forth. And periods are combined to make subdivisions called eras: the Paleozoic era, the Mesozoic era, the Cenozoic era, and so on and so forth. And an eon is the largest period of geological time, and the division of time units in geological time scale is usually based on the occurrence of significant geological events. For example, mass extinctions. For example, we have heard about dinosaurs. Okay, dinosaurs this time are not existent on Earth. So geologists will study the different life forms and will associate it with a significant geological event and give it time scale. Chronologically, we have seen these different time scales. Now, when we give age dating techniques, there are two techniques of knowing the age of rocks: relative and absolute age dating. By relative dating means we use geological evidence to assign comparative ages of fossils. Different fossils were seen at different times. So by examining or by assigning comparative ages of fossils, we give dating of ages. The second one is absolute dating, also known as radiometric techniques. By using different techniques like radiometric techniques, we give dating. So the regular rates of decay for unstable radioactive elements were found to constitute virtual clocks within the Earth's rocks. So when we study using these two techniques, we can say that at the end of the day, the regular rates of decay for unstable radioactive elements, that we have found it on the crust of the Earth, meaning that on the outer surface of the Earth, were found to constitute virtual clocks within the Earth's crust. So geology study in such a way. Now when you go to the geological processes of the Earth, or that results landforms of Ethiopia and so on, the Precambrian era geological process took from 4.5 to 600 billion years ago. Look how old it is. And it covers 5/6 of the Earth's history due to its remoteness. In time and the absence of well-preserved fossils, our knowledge of the pre-events is limited. So a lot is not known about the Precambrian era. Simply what we know is that, or what geographers know is that, there was a period, an ancient period without life, which is called, what we call it, the Precambrian. So the major geological events of the Precambrian era, simply what has been observed during this era was that orogenesis. Orogenesis means mountain formation was seen in the Precambrian era. Then the land was subjected to intense folding. This was accompanied by intrusive igneous activity. When we study about rocks, there are three different kinds of rocks: sedimentary rock, igneous rock, and that of metamorphic. Igneous rocks are rocks that are to be formed by high heat as a result of volcanic activity and so on and so forth. So during that period, the result was the formation of huge mountain ranges because of volcanic eruption and other intrusive igneous activity. What we have seen in the Precambrian era was what we call it orogenesis. In between the orogenic periods and after the last orogenesis, there were long periods of denudation which finally reduced these mountains to new level peneplain rock surfaces. First rocks, found mountains were formed, and later by that of external or internal forces, these huge mountains that which were formed during the period of orogenesis or mountain formation later started to go to a peneplain rock surface. Because of weathering and other activities, it starts to lower and come to denudation after a long period of time. This level suffers was later seen in the Mesozoic and Cenozoic eras, what we call it, which was covered by younger rock formations. In sedimentary rock, what we see that in a specific period of time, some sediments will be formed, okay, or sediments will be accumulated in one area. They will start to harden and they will form a rock. In another era, it could be through wind erosion or water erosion. Another layer will come over the underlying. It goes on, it goes on, it goes on, and it will form a rock. So this kind of rock formation is called what we call it sedimentary rock. So these are rocks that are to be formed from the sediment or settling down of sediments. In here, in most parts of Ethiopia, rocks belonging to this area are found beneath all other rocks forming the basement rocks. They are found to be in the lower part of the earth because other rocks have been formed over these rocks. They have been subjected to pressure and heat, forming overlying weight, earth movements, folding, orogenesis, and to intrusive igneous activity. As I have told you, the lower one or the underlying rock will start to harden, and because of high heat, finally it will go for what we call it intrusive movement, volcanic eruption. The original rocks, both sedimentary and igneous, were altered into metamorphic rocks of varying stage of metamorphism. We have first these rocks, what we call it sedimentary, that are to be formed by settling down the sediments, and also igneous, that are to be formed from that high heat. And finally, these rocks, after many years, will start to harden and form a metamorphic rock. So metamorphic rocks are rocks that are changed either from sedimentary or from igneous rocks. So these are very strong rocks, and a good example of this could be what we call it marble. Since these same processes have allowed mineralization in crystal formation, the rocks are also collectively described as crystalline rocks because they do have so many crystals within them. So they are found exposed in the following areas when it comes to Ethiopia. One is the northern part, western lowland parts of the northern and central Tigray. In the western part, Gambella, Benishangul, Gumuz, Metakal area, and Azusa, western Gojam, western Walaga, Elbabur, and Abai Gorge area. Two, in the southeastern part, Guji, southern Omo, and parts of southern Bali, we will find this kind of rocks. These kind of rocks are to be found in this area. The third area where this kind of rocks are to be found is that in the eastern part of Ethiopia, particularly in eastern Hararghe. So these are what has been observed during that period. The Paleozoic era. The geologic process from 600 million to 225 million years ago lasted for about 370 million years. So it covers for about 375 years, million years. The major geological process of this area, meaning that major features that were seen in the Paleozoic era was denudation, meaning that gigantic mountains ranges were reduced to a peneplain surface. They started to lower. The sediments were transported southward and eastward to form continental, for example, in Africa, and marine deposits respectively. Marine refers to sea, okay, respectively. Because of the limited deposition within Ethiopia, rocks belonging to this area are rare in the country because there was not huge, deposition in Ethiopia, so that we don't have ample evidences about this area. The Mesozoic era, when we talk about the Mesozoic, it was an area of alternates of slow sinking and rising. What we call it epirogenesis. Epirogenesis refers to a process where the land is either to sink or to rise because of the land mass, because of the different reasons. This process affected the whole present-day Horn of Africa and the Arabian landmass. The land was tilted eastward and therefore lower in the southeast and higher in the northwest because of slow sinking. As the land sinks slowly, the sea invaded it, starting from the Somalia and Ogaden and slowly spreading northeastward. Why? Because it's a lowland, it sinks, so the water from the sea starts to invade it, okay? To invade it. The latter is associated with the flourishing of marine life and decaying and precipitating of their remains as the sea stayed low. Meaning, as we know that the water from lakes and seas is highly saline. When this water comes to the land surface and whenever there is high level of evaporation, what will remain is that salt as a sediment. That's why if we are to go to areas of the Afar region, we'll see a huge land, a huge deposit of salt in these areas. So the Mesozoic rocks are considered to have the greatest potential for oil and gas deposits. Through time, compression, okay, by the overlying rocks and by cementing minerals, the sands and lime were compacted to form sandstone and limestone layers respectively. These are good examples of sedimentary rocks. Sandstone and limestone are rocks that are formed from the settling down of sediments. As we have said, during the Mesozoic era, when there was no rising and sinking of the land, okay, these areas were covered by sediments, and these sediments finally formed what we call it the two rocks, sandstone and limestone. These are known as the underground sandstone and Hintaro limestone layers in northern area. So the sandstone, since it was found around these areas, we call it underground sandstone and the Hintaro limestone rocks. In the Horn of Africa and Ethiopia, the slow rise of the land and consequently the regression of the sea began in the upper Jurassic, okay, because this Mesozoic era has three periods: Triassic, Jurassic and that of Cretaceous. So during the Jurassic period it starts, or meaning that the sea began, okay, to regress in the upper Jurassic period. It continues throughout the Cretaceous period up to the last period of the Mesozoic era. With the retreat of the sea, another process of deposition occurred. When the sea retreats backward, In the country, sedimentation ended with the deposition of clay, silt, and sand conglomerate brought in from the land as the sea receded due to uplift of the land masses. Gypsum, shale, and lastly sands were laid over the Hentaro limestone, because the Adigras sandstone and the Hentaro limestone were old. Over them we observed the occurrences of these minerals like gypsum, shale, and so on and so forth over the Hentaro limestone. By the end of the Mesozoic era, when the land emerged out of the sea, three major sedimentary formations were laid and formed upon the Precambrian rock surface. These were: one, the Adigras land or lower sandstone. Over the Adigras sandstone, there was Hentaro limestone, and upper sandstone finally were observed in this era. The Adigras sandstone is older and thicker in the southeastern and progressively decreases in age and thicknesses northeastward. The third one, the Cenozoic era geological process from 70 million years ago up to present time, is the most recent of the geological era. And the major geological events and other geological processes include: one, uplifting of the Arabo-Ethiopian landmass was uplifted and outpouring of huge quantity of lava from it. The lava started to come out of the surface of the earth. Two, the formation of the Rift Valley, especially the East Africa Rift Valley. Three, quaternary volcanism and deposition was seen during this period. Uplifting of the Arabo-Ethiopian landmass and outpouring of lava flood is a continuation of the slow rise that began in the Upper Jurassic and Cretaceous. These Jurassic and Cretaceous were, periods within the Mesozoic era. The land was pushed up to maximum height of 2,000 meters above sea level from in. This occurred during the Eocene epoch, where the whole of the Arabo-Ethiopian landmass was pushed up in blocks as one mass. So the greatest uplift was in the central Ethiopia. This immense tectonic force also fractured the crust of many places. Its structures it started to fracture. So a huge quantity of lava come out of these fractures. As we know that volcanic eruption is the result of intrusive activity. First, within the crust of the earth, the rock materials will be changed into a molten rock called magma. And when this magma is to be pushed upwards by high pressure and heat, it will come to the surface of the earth through different fractures as lava. This is the process. So the outpouring of this flood of basalt spread widely and extensively and covered a large part of the Mesozoic sedimentary rock layer to form the Ethiopian plateau surface and also the floor of the present day Rift Valley. So the present day floor of the Rift Valley was formed during this period because of volcanic activity. Okay. Reverse tilting. Reverse tilting and volcanic activity later in the Pleistocene period blocked the connection and isolation of the extension of the sea, allowing much of the water to evaporate. As a result, thick saline materials accumulated. During the same period, the area between the Danakil Depression or the Danakil Depression and the Red Sea was uplifted to form the Afar Block Mountain. So the Afar Block Mountain is a result of this processes. The Ethiopian Rift Valley is part of the Great East African Rift System, okay, which goes from Syria to Mozambique, okay, across Ethiopia. The Rift Valley region of Ethiopia is the most unstable part of the country because it is a fault line. It's a weak part, so anytime volcanic eruption, earthquake, and other things could happen within this rift system. There are numerous hot springs, fumaroles, active volcanic geysers, and frequent earthquakes are to be seen within the Rift Valley. So when we go down to the Rift Valley, we will find, many hot springs across this region. The formation of the Rift Valley has the following structural or physiographic effects. One, it divides the Ethiopian plateau into two. It separates the Arabian landmass from the African landmass. It causes the formation of the Dead Sea, Red Sea, and the Gulf of Aden troughs. It creates basins and fault depressions on which the Rift Valley lakes are formed. We do have so many Rift Valley lakes within the Ethiopian Rift Valley. Okay? Good. We have seen what had happened during the tertiary period. During the quaternary volcanic eruptions and depositions, these are the recent volcanic activities that took place after the formation of the Rift Valley. This occurred in the Pliocene and Pleistocene epochs. This activity was generally limited to the floor of the Rift Valley and the region south of Lake Tana, where the lava covers an area of more than 3,000 kilometers or square kilometer. Look how it covers a large area because of a huge lava flow. The quaternary volcanic eruptions and depositions are recent volcanic activities. They are very, very recent volcanic activities. The heavy pluvial rains eroded the Ethiopian plateau, and the eroded material is deposited in the Rift Valley. Since the Rift Valley is a lowland area, because of torrential or heavy rainfall, when the highland area plateaus were eroded, the eroded materials through this water was transported and deposited in the Rift Valley lakes, because these water bodies are to be found within the Rift Valley. Lake and marshy areas become numerous and deep. Many were enlarged and covered much area and even merged together. For example, Zuwai, Langano, shallow, Hawassa, shallow, Chamu, Abaya, and Lake Abe, and the nearby smaller lakes and marsh basins formed hugely. So all these lakes are to be found within the Rift Valley of Ethiopia. Today, there are lacustrine deposits of continental origin. Okay, lacustrine refers to sea areas around many of the Ethiopian lakes, rivers, valleys, and lowlands. According to the place and manner of deposition and depositing agents, these deposits are divided as follows. Lacustrine deposit A, deposits in former lakes or lake bed. So deposits that are to be found on lake beds, swamps, depressions, and so on and so forth are called lacustrine deposits. Fluvial deposits are deposits on the bank of a river. Okay, on the bank of a river. Okay, the two sides of a river is called a bank of a river. Floodplains. Okay, a lowland area, very lowland area, both in plateau, foothills. Okay, if you are to see deposits in this area, we call it fluvial deposit. The third one, glacial fluvial deposits and erosional features. These are occurred on high mountains. Okay, glacier refers to glacier. meaning that snow, such as the Bali and the Kaka mountains. The deposits that are to be found in this highland area is called glacial-fluvial deposit. LIN deposit, the first one, is a deposit, okay, that has resulted because of wind. If a wind, okay, brings sediments and deposit it in some area, or wind-blown deposit, we call it iodine deposit. So these different namings are given in such a way. The fifth one, coastal and marine deposits, are deposits on sea invaded and sea covered places. So the quaternary depositions are mainly found in the Rift Valley, Afar and Lakes region, Barrow lowlands, southern Borno, and parts of northern lowlands of Ethiopia. These are all what we call them quaternary deposits. Rock and mineral resources of Ethiopia. Ethiopia do have different minerals. The occurrence of metallic minerals in Ethiopia is associated with the Precambrian rocks. Okay, these old rocks are believed to have a huge metallic mineral. These rocks contain most of the metallic deposits known as at present. At present, we know this. The current state of main minerals in Ethiopia looks as follows. Geological surveys prove that Ethiopia has abundant mineral resources of metals and precious metals, coal and industrial minerals. For example, some of the minerals of Ethiopia include gold. Gold has been mined in Ethiopia for quite a long time, mainly from Benishangul Gumuz, Metakel area, and Dola. Platinum. The Yubo area in Wolaga is the only active Ethiopian platinum mine. Tantalum is also to be found in Ethiopia. Tantalum is to be found in Ethiopia. Okay? Tantalum. Okay? Significant deposit of tantalum and niobium is found in southern Ethiopia. The sedimentary and volcanic rock activities are also resourceful for tantalum to be formed. Gemstones. Gemstones including amethyst, aquamarine, emerald, garnet, opal, beryl, sapphire, and tourmaline occur in many parts of Ethiopia, mainly in Amhara and Oromia regional states. Potash. The potash presence in the Danakil or Dalo depression of the Afar region is believed to be significant. There is a huge deposit of potash in this area. Gypsum and anhydrite, a limited amount of gypsum is produced for domestic consumption of Ethiopia, mainly for the cement industry, but very large deposits are known to occur in sedimentary formations of the Red Sea coastal area, the Danakil depression, the Ogaden, the Shoa area, Gojam, Tigray, and that of Hararge. We will find this. Clay. Ethiopia is endowed with industrial clay material. Alluvial clay deposits for bricks and tile, pottery, and pine industry occur in Adola, Abai Gorge, and the Rift Valley Lakes region. Marble. Okay, crystalline limestone. Okay, crystalline limestone is widespread in the basement rocks of Ethiopia. Marble has been quarried in such localities at west of Mekelle, and south of Adwa and Tigray. So marble is highly to be found in the north part of Ethiopia, where there was a huge deposit, okay, especially in the basement rocks. In the eastern, in Galati, Soka, Ramis, Rochelle, Kumi, and other bodies of Charter Mountains in western Hararge is also to be found. Construction rocks: basalt, granite, limestone, and sandstone are important building stones, especially for construction. Like what? Road construction. For example, granite is very good for the construction of roads. For the surfacing of roads and compaction, basalt, scoria, and other volcanic rocks are extensively used. Okay. Mesozoic limestone is an important raw material for cement and chalk production. Limestone, as we know that chalk is to be formed from that of limestone. The earlier cement workers, or so cement is also to be formed from limestone. The earlier cement workers at Redon and the recent ones at Mugar Valley, Abai Gorge region, Tigray, Mesobo are using similar raw materials from these rock formations. That's all about chapter 2.